Hello, in this video we're going to look at calculating the hydronium ion concentration if we know what the pH is. Remember, pH is minus the log of the hydrogen ion concentration or minus the log of the hydronium ion concentration. So the inverse process would be that the hydronium ion concentration or the hydrogen ion concentration is equal to 10 to the minus pH. So you need to learn how your particular calculator works in doing this calculation. But we're going to do three examples. In the first one, if we have a pH of 3.0, what's the hydronium ion concentration? And so if you recognize that this pH is an 00, that means the concentration has to be 1.0, and if you recognize the characteristic of being 3, that means 10 to the minus 3. And so you don't even have to do the calculation if you can recognize that. If you do need to do the calculation, it's 10 to the minus pH, or 10 to the minus 3.00. And so you'll need to put that in your calculator. And when my calculator works, I'm putting in 3, changing the sign, and then I got an inverse log button that allows me to see that it comes up as 0.001, which is also 1.0 times 10 to the minus 3. So remember about significant figures and pH numbers that are logarithmic numbers. The only significant figures are located the number of decimal places that you have. And so we had 2 digits in the two decimal places, and so our base 10 number, which is what our hydrogen ion concentration is, will have 2 sig figs in it that corresponds to the 2 decimal places in the pH. So that's what our hydrogen ion concentration is. The next example is pH is equal to 5.62. That's a pH that's less than 7, so that's an acidic solution. So the hydrogen ion concentration, or the hydronium ion concentration, is 10 to the minus pH. And we can't just do this in our head like we did the first one, where we had a number that's 1.0. So 10 to the minus 5.62. In my calculator, I'm going to do 5.62, change the sign, inverse log, and I will get 2.4 times 10 to the minus 6 molar. I need to put a concentration back up there with my other answer. So 2.4 times 10 to the minus 6 molar. Had 2 decimal places in my pH. That means I'm going to have 2 significant figures in my hydronium ion concentration. And the third and last example I want to do is if we have a pH of 8.91. So the hydronium ion concentration is equal to 10 to the minus 8.91. And that would give me an answer of 1.2 times 10 to the minus 9. And so this was a solution that was alkaline or basic. It's got a pH greater than 7. And so you got a very low hydronium ion concentration of 1.2 times 10 to the minus 9. So the important things out of this lesson is to know that formula, that hydronium ion is equal to 10 to the minus pH, and learning how to use your calculator and which buttons you need to press and what sequence to carry out that function. Thanks for listening.